Hi guys, welcome back to Math with OG. If this is the first time of you watching our video or you've seen our video before and you are yet to subscribe, please do well to use the subscribe button and also like the button and also use the like button. It will cost you nothing so that it can reach more people. Now let's cut to the chase. In this video, we'll be looking at Venn diagram interpretation. For those of you writing Jamb, Waec, Neco, any O-level exam, be it in Nigeria or outside the country. There are cases where they test your knowledge on how well you understand Venn diagram. So how can you interpret Venn diagram? That's what we'll be looking at. Now we'll be giving the standard answer to questions, though I think I've mentioned before that you can have more than one interpretation of Venn diagram. That means this, for example, this being the solution to this Venn diagram problem does not mean that this is the only solution to the Venn diagram problem. So in case you don't come across this, you might come across something else, and it's not left for you to check on your own, work on it to know which of them is the correct answer. So using this as the first question, as our case study, this is our first question. How do we interpret Venn diagram? Now this is our universal set. Now this circular, not a perfect circle, but you can see that it is curved. This circular part are our three subsets. So we have subset A, subset B, and subset C. Now, from what you can see here, everything in subset A is shaded. So if you are asked to interpret this Venn diagram, your answer is simply A. So this Venn diagram is equal to A. So what was shaded was subset A. So we can use this to form other Venn diagram. That means if all what was shaded was just the B part, the Venn diagram will be B. And if all what was shaded was just the C part, the Venn diagram will be C. Very straightforward. Like I said, everything in A was shaded, not some part of A. So once everything in A is shaded, the answer is A. Once everything in B is shaded only, the answer is B. If everything in C is shaded only, the answer should be C. Now let's move to the next one. In this case, you observe that if I also form subset B, I'm going to be shading everything in this blue circle because this blue circle is presenting subset B. Now you can see that everything in the blue circle is not shaded. Rather, everything outside the blue circle is shaded. That simply means the complement of subset B. Because if this is the universal set, everything here is what belongs to set B, and everything outside B is what belongs to the universal set but not in set B. So this guy is B complement. So if peradventure everything outside A was shaded, only A was unshaded, then you have A complement. Similarly, if only C was unshaded, everything outside C is unshaded, what we have here is simply C complement. For example, you can see it here. So everything shaded here is C complement because everything in C is not shaded, but everything outside C is shaded. So this is C complement. Now over to the next one. You can see that what we have here is A intersect B complement intersect C complement. So there was a reason why I did 1, 2, 3 first before that particular one. Now on your own, you can check. Look at your subset A. I believe you can see it. Look at your subset B complement and look at your subset C complement. So what is common to A, B complement, and C complement? What is common to A, B complement, and C complement? If you check properly, the only part that is similar to A, B complement, and C complement is this part that is A only. That means this part is not common to all of them. Because if you look at this particular part here, you can't find it here. You can't find these two parts here. And this last part, though you can find it here, you can't find it here. But this particular part in A that is presenting A only, you can find it here and you can also find it here. So this part here is the intersection of A, B complement, and C complement. This part here is the intersection of A, B complement, and C complement. That means this part is common to both is common to A, B complement, and C complement. So in similar fashion, if I'm to shade this part, now this is simply B only. I'm shading B only. If I'm to shade this part, This will no longer be A intersect B complement intersect C complement. It will now be A complement intersect B intersect C complement. That means I shaded B only. So this part here, only B is common to B, C complement and A complement. Then lastly, if I'm to shade only C, 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 this will be A complement intersect B complement intersect C. So I believe you understood what we did. So this solution is for this black shaded part, this solution is for this blue shaded part, and this solution is for this red shaded part. Now let's move on to this. Now you can see I have subset A, subset B and subset C. What I shaded is what is common to A and B. So everything here is common to A and B, though this part here is common to A, B and C, but it is obvious that everything here from here to here is common to A and B. So if I'm to shade subset A and to shade subset B, this part will be shaded in both subset A and subset B. So we call this guy A intersection B. We call this guy A intersection B. However, if I'm to shade this part red and also shade this part that is common to A, B and C, shade this part common to A, B and C, this will now be what? B intersection C. So this will be B intersection C. Similarly, if I'm to shade this part common to A and C only, and this same part common to A, B and C, that means everything from here down to this innermost part, this will be A intersection C. Now let's move on to this Venn diagram. You can see that in this case we are not shading A intersection B intersection C. That means what is common to A, B and C. However, we are just shading what is common to A and B only. We are avoiding what is common to C. So this is A and B only. This is A only. This guy here is A and B. This guy here is A and B only, because we are not adding what is common to C. So this is simply A intersection B intersection C complement. So if I'm to shade this part, only this part, I'm not adding what is common to A, B and C. This red part will be, this red part here will be A complement intersection B intersection C. Lastly, if I'm to shade this part, this will be A intersection B complement intersection C. Like I said, these are not the only solution. I I I think, or I remember that we've done something called De Morgan's law. So if I'm to use De Morgan's law to get another solution, if I want to get another solution from this guy here, A intersection B complement intersection C, I believe that I can get A union B union C. Sorry, A complement union B union C, or in bracket complement. So you can check that on your own. Try and draw this diagram on your own. You will see that the answer will be correct. So you draw A complement, you shade B, you shade everything that you can find in A complement B and C. And when you are done shading everything you can find in A complement B and C, you see that this part here, where is it? This part here will not be shaded. But when you shade everything in A complement, you are going to shade everything outside A. Now, when you shade everything in B, you are going to shade everything inside B. When you shade everything in C, you are going to shade everything inside C. You observe that this part that is A only will not be shaded. So this part that will not be shaded is simply the complement of A complement union B union C. Now this guy here will be A union B complement union C, all complement. This guy here will be A union B union C complement, all complement. So you can go back to our previous video where we did law of algebra of sets. Then you can use that to get the other solutions to this question. Like this guy here can be written as A union B union C, all complement. A union B. Okay, no, that's not the solution. That's not the solution for this case, because A union B union C, or complement will be outside everything. So you can't use that for this. but it will work. Sorry, okay, I was getting it wrong. This guy here, remember, this will be A complement. Yes, this is A complement union, B complement union, C complement, all complement. So that should be the answer. So everything A complement is everything outside A, everything B complement is everything outside B, everything C complement is everything outside C. You see that at the end of the day, this guy here will be untouched. So this guy here will be the complement of whatever you have here. So this is simply A intersection B intersection C. That's what is common to A, B, and C. Lastly, what I have here is if I were to shade everything here, so let me do the shading of everything here in this particular question. I believe we understood that this is C complement already. So let's assume okay, where will I work? Okay, let's do that here. We know this is A already, so if I'm to shade everything here, it is obvious that what I now have here is A union B union C, no longer A. So everything outside this guy should be the complement of A union B union C. So we can write this guy as A union B union C or complement. You can see that De Morgan's law is also working for this particular question. So this can be written as A union B union C or complement, or A complement intersection B complement intersection C complement. So when you shade your A complement, you shade everything outside A, B complement everything outside B, C complement everything outside C. So what is common to these guys will be everything without touching A, B, and C. So this is what you have to be your final answer. So these are the few common questions you see under interpretation of Venn diagram. So I expect you to play back the video if there's anything confusing. So I believe if you watch it more than once, it will make it clearer. And also write as you watch the video. Try and bring out all the various subsets on your own and check what is common. What do I mean? You can try and shade that A complement on your own, shade that B complement, shade that C complement. So you'll be having three Venn diagrams, three separate Venn diagrams. Then check your A complement, your B complement, and C complement. What is common to the three? Use that to form a new Venn diagram, and you see that you are going to have this to be your answer. Same thing you can do here. Shade A, one Venn diagram, shade B, another Venn diagram, shade C, another Venn diagram. Try and compare the three diagrams. What is common to the three of them? You find that this will be your final answer. Just the same way we did for A, B complement, and C complement to form A intersection B complement intersection C complement. So that's that for that. Now next video we'll be looking at solving set equations. So we'll start with two subset questions, then we'll move on to three subset questions, and I believe that will be all for said before we move on to a new topic. So thanks for watching. If you find this video to be helpful, kindly use the subscribe button. Don't forget to share, and also use the like button so that it can reach other people to see this video. And don't hesitate to use the comment section if there's any error in what we did, or if there's any question you wish to ask, you can leave that in the comment section. Thanks for watching once more. See you guys in my next video.